Let's take a look at Unit 5, Rational in Radical Expressions. Let me share my screen. Now, our first learning objective, there's quite a few. Add, subtract, multiply, divide, and simplify rational expressions. Find LCM of polynomials. And express two fractions in terms of the LCM of the denominators. First off, let's talk about simplifying rational expressions. Say we got x squared minus 5x plus 6 over x squared minus 4. Get this up and running. Simplify rational expressions. Step 1. Back to the top, numerator. Back to the bottom, denominator. Cancel if possible. Now when we say cancel, everything on top has to be multiplication, everything on the bottom has to be multiplication. The x squareds here are the same, but we can't cancel those because we got subtraction and addition in here. So everything has to be multiplication. That's why we do step 1, we factor. Well, step 1 factory involves the PSD method on top, because we got x squared x, no number in front of x squared. And the difference two squares on the bottom, because we got two terms of the minus string in it. The top factors is x minus 2 times x minus 3. And the bottom factors as x plus 2 times x minus 2. That was step 1. Factor the top, factor the bottom. Step 2, cancel if possible. Notice here this x minus 2 here is the same as this x minus 2 here. So those are going to cancel. And that leaves us x minus 3 over x plus 2. Now the reason why these would cancel away is because this is multiplication. We got x minus 2 times x minus 3. Down here we got x plus 2 times x minus 2. Here we can't cancel the x's because it's not multiplication. There's subtraction here and addition here. So this would be our answer. And that's simplifying rational expressions. Well, let's take a look at multiplication. Since I have x squared minus 7x plus 10 over x squared minus 25 times x plus 5 over x squared plus 10x plus 25. Multiplying rational expressions. Step 1, factor everything. So all the numerators, all the denominators. Step 2, cancel if possible. Guideline is 1 is on top, 1 is on the bottom. They don't have to be in the same fraction. They can be, but they don't have to be. Just something's on top, something's on the bottom, they're the same. And then we'll multiply the tops, and we'll multiply the bottoms. Most times we don't actually multiply them together, you just put them next to each other. Okay, step 1, factor everything. This is PSD. Because we got x squared x, no number in front of x squared. X plus 5 I can't do anything with. X squared minus 25 is difference two squares, two terms of minus 3 in it. And this is PSD. So those factors as x minus 2 times x minus 5 This factors as x plus 5, x minus 5. X plus 5 can't do anything with. This factors as x plus 5 times x plus 5. Okay. Now cancel. Guideline is one's on top, one's on the bottom, they're the same. X minus 5, x minus 5. Those are the same. X plus 5, x plus 5. Those are the same. Again, one's on top, one's on the bottom, they're the same. Now these are the same, but they're both on the bottom. So I can't cancel there. Okay, now we're going to multiply top parts together. There's only one thing left on top, x minus 2. And the bottom part. So I'm going to write that as x plus 5 times x plus 5. Or you could write x plus 5 squared. Typically, you don't actually multiply it through, though. And that would be our answer. Let's take a look at division. Now, step 1, we're going to immediately rewrite as multiplication by flipping the fraction following the division symbol. It's called reciprocal. That's not spelled right, but well, it is. So rewrite as multiplication by flipping the fraction following the division symbol and changing the symbol to multiplication. And then step 2 is we'll multiply like normal. That's just what we did up above. Okay, I'm going to clear this off. So let's say we got 2x squared plus 3x minus 2 over x squared plus 6x plus 8 times 4x plus 8 over 4x squared minus 1. Oops, that's division. Let me change that. There we go. Step 1. Immediately rewrite as multiplication. So before we do anything else, we're going to flip that fraction, fall into division, change the division symbol to multiplication. Again, top goes to bottom, bottom goes to top. This is reciprocal. Reciprocal means fraction flipped. Now we're going to factor everything. This up here is key number. This down here is PSD. This right here is GCF. This is difference to squares. So this is a factor as 2x minus 1 times x plus 2. This bottom factors as x plus 2 times x plus 4. I can factor 4 out of that, and that leaves me x plus 2. And this factors as 2x plus 1 times 2x minus 1. You get very good at factoring on these. Next step is we want to cancel. Guideline is one's on top, one's on the bottom of the same. 2x minus 1, 2x minus 1. One's on top, one's on the bottom. X plus 2, x plus 2. One's on top, one's on the bottom, they're the same. And I guess that's it. So put the multiply tops together, basically put them next to each other. 4 times x plus 2. Multiply the bottoms together. Again, just put them next to each other. And that would be our answer. Grab a drink here, and then we'll just take a look at addition and subtraction. These problems look hideous in this intermediate algebra, but they're really not too bad if you know how to factor. If you don't know how to factor, then that's where they can become challenging. Okay, so let's take a look at adding and subtracting. So adding, subtracting rational expressions. Step 1, get a common denominator. And the first thing we do is we factor all our denominators. Figure out the LCM of all the denominators and multiply everything by it. And multiply the top and bottom such that each fraction has the new denominator. Okay, step 2. Add, subtract the tops and put into a single fraction. And then simplify the fraction. Okay, so let's take a look at this. Let's say we got 5x minus 1 over x plus 2 plus x plus 3, I guess. Doesn't much matter. Now these already have the same denominator, so I don't do step 1. Step 2, add or subtract top parts. So 5x plus x is 6x. Negative 1 plus 3 is 2. Our last step would be to simplify. Now I'm going to try it. The top part factors, I can factor out a GCF of 2, and that gives me 3x plus 1. The bottom part I can't factor at all. Now once I factor out GCF on top, I notice that nothing will cancel, so that'll be our answer. Okay. Let's take a look at this problem. Step 1, again, is already done. They have the same denominator. Our next example will be one that doesn't have the same denominator. So we'll add or subtract tops. Now, this one's kind of tricky. When you're doing subtraction and you got a fraction, this minus here, this negative, has to flip the sign of everything on top. So when I merge this into a single fraction, the positive 6x has to become a negative 6x. The positive 7 has to become a negative 7. And the bottom remains as is. 7x minus 6x is x. 2 minus 7 is negative 5. This one we can actually simplify. X minus 5 over x minus 5 gives us 1. And that'd be our answer. Okay, let's take a look at one with different denominator. Let's say we got 2x over x minus 5 plus 3 over x plus 1. We're starting out with a fairly simple one, then I'll get a little bit harder. Step 1, get a common denominator. Our first sub-step of that says to factor all the denominators. These can't be factored. Our next sub-step says figure out the LCM of all the denominators and multiply top and bottom such each fraction has a new denominator. Okay, we'll start with the first factor, x minus 5. I'm looking for the greatest number of x minus 5 in a single denominator. There's 1 here, there's none here. So the greatest number of x minus 5 in a single denominator is 1. Go to our next factor, x plus 1. We're looking for the greatest number of x plus 1s in a single denominator. There's none here, there's 1 here. So the greatest number of x plus 1s in a single denominator is 1. Now, that was our LCM, so we're going to rewrite each fraction with that. Notice I indicate you're going to multiply top and bottoms such that each fraction has a new denominator. Our first fraction here, the old denominator is x minus 5. That's still there. The new item down below is the x plus 1. So we're going to multiply the top part by x plus 1. The mathematical principle behind that is wherever you multiply by the bottom, you have to multiply by the top. Over here, our second fraction, our old denominator is x plus 1. The x plus 1 is still there. The new item down below is x minus 5. So we're going to multiply the top part by x minus 5. 2x times x is 2x squared. 2x times 1 is 2x. And denominator stays as is. 3 times x is 3x. 3 times negative 5 is negative 15. Denominator stays as is. Now notice that they have the same denominators now. So I merged together the top parts. So I got 2x squared. 2x plus 3x is 5x minus 15 over x minus 5, x plus 1. I doubt that'll actually factor. Let me think it through. 1 times 30, 2 times 15, 3 times 10, 5 times 6. No, it doesn't. When I make up problems, I almost never factor and simplify at the end. And that'll be our answer. Okay, let's take a look at a little harder one now. Okay, 3 over x squared minus 4 plus 7 over x squared minus 5x plus 6. Step 1. Get a common denominator. First sub-step is to factor all our denominators. This factors as difference 2 squares. This factors as PSD. So I got 3 over x plus 2, x minus 2, plus 7 over x minus 2, x minus 3. Okay. Now we've got to figure out what our LCM is. So we'll start with our first factor, the x plus 2. Now I'm looking for the greatest number of x plus 2s in a single denominator. There's 1 here, there's none here. So the greatest number of x plus 2s in a single denominator is 1. I go to my next factor, the x minus 2. I'm looking for the greatest number of x minus 2s in a single denominator. There's 1 here, there's 1 here. So the greatest number of x minus 2s is 1. And the x minus 3. The greatest number of x minus 3s in a single denominator. None here, 1 here. That'll be 1. So that's going to be our LCM. Now again, you're figuring out what to multiply top and bottom by. So if we look at our old denominator, here's an x plus 2, that's still there. X minus 2, that's still there. The new item down below is x minus 3. So we have to multiply that by the top. Whatever you multiply by the bottom, you have to multiply by the top. Over here we got an x minus 2. X minus 2 is still there. Here we got an x minus 3. X minus 3 is still there. The new item is x plus 2. So I'll put that up on top. So then 3 times x is 3x. 3 times negative 3 is negative 9 over our denominator. Plus 7 times x is 7x. 7 times 2 is 14 over our denominator. Then I want to combine the top parts. 3x plus 7x is 10x. Negative 9 plus 14 is 5. Yeah, 5. Then our last step would be to simplify. Although this is not going to go anywhere. I can factor a 5 out of the top, the GCF. And that gives us 2x plus 1. Once I do that, though, nothing will cancel with anything on the bottom. So that'd be my answer. Again, typically they don't multiply them back through. They leave them like that for the answer. Okay. Now this one talks about equations involving fractions. These are called rational equations. Let me grab a drink first. First off, let's specifically talk about proportions. Now, proportion is when you got a single fraction equal to a single fraction. If you got a proportion, what you're going to do is you're going to cross multiply. So you'll take 3 times x plus 5, and you'll take 7 times x minus 1. So I got 3 times x plus 5 equals 7 times x minus 1. 3 times x is 3x. 3 times 5 is 15. 7 times x is 7x. 7 times negative 1 is negative 7. Get everything with an x on one side, numbers on the other side. So I take 7x over. So you get 3x minus 7x equals negative 7 minus 15. That gives us negative 4x equals negative 22. Yeah, negative 22. Divide both sides by negative 4. And negative divided by negative is positive, so that cancels. And top and bottom both divisible by 2, so that gives me 11 halves. Now you do need to make sure that this does not cause any denominator equals 0, but I don't have any variables in my denominator, so I don't need to worry about that. So that's our answer. Now let's say I had a rational equation. I'm making this up, so hopefully it comes out decent. Sometimes when I make them up, they come up with I think I would have come up with a weird answer. Solving rational equations. Rational means a single fraction with a variable in the denominator. So you've got an equation that has a single fraction with a variable in the denominator. Step 2 or step 1. Get rid of parentheses, even though I don't think I hardly ever see that. Step 2 is the important one in terms of starting out. Get rid of fractions. And how we do that is we factor all our denominators. Figure out the LCM of the denominators and multiply everything by it. And then step 3, we're going to solve for x. At this point, it might be linear or it might be quadratic, although it could even be other items. And then step 4 is we'll semi-check our answer. We'll see what in the world that means. Okay, step 1, get rid of parentheses, don't have any. Step 2, get rid of fractions. We're going to factor all our denominators. X squared minus 4 is difference 2 squares. X plus 2 and x minus 2 I can't do anything with. So this becomes 2 over x plus 2, x minus 2, plus 3 over x plus 2 equals 10 over x minus 2. Okay, and I figure out our LCM. I start with my first factor. I'll start out with x plus 2. I'm looking for the greatest number of x plus 2's in a single denominator. There's 1 here, there's 1 here, there's none here. So the greatest number of x plus 2's in a single denominator is 1. Then I go to x minus 2. And I'm looking for the greatest number of x minus 2's in a single denominator. 1 here, none here, 1 here. So the greatest number of x minus 2's in a single denominator is 1. Now we're going to multiply this times our first fraction. We'll multiply it times our second fraction. And we'll multiply it times the fraction on the right side. So x plus 2 and that x plus 2 will cancel. That x minus 2 and that x minus 2 will cancel. And that x plus 2 and that x plus 2 will cancel. And this x minus 2 and this x minus 2 will cancel. So that leaves us 2 here, plus 3 times x is 3x. 3 times negative 2 is negative 6. 10 times x is 10x. 10 times 2 is 20. So we got 2 minus 6 is negative 4. I want to get everything with an x on one side, numbers on the other side, so I take 10x over. Becomes a negative 10x. Take the negative 4 over, it becomes a positive 4. So we get negative 7x equals 24. And then divide both sides by negative 7. And you get x equals negative 24 over 7. Now we need to semi-check our answer. What we mean by that is we want to plug this into the x's here and make sure it doesn't cause any denominator to equal 0. Negative 24/7 squared minus 4, I don't know what it is, but it's not 0. Negative 24/7 plus 2 is not 0. Negative 24/7 minus 2 is not 0. The numbers that would have caused this problem is if I ended up with a positive 2. If I put it here, 2 minus 2 would have gave me a 0, and I can't have a 0 in the denominator. If I'd come up with a negative 2, negative 2 plus 2 would give me a 0. And we can't have a 0 in the denominator. So you don't need to fully check it, but you do need to make sure that you didn't get an answer that gives you a 0 in the denominator. Okay, let's see. Now we're getting to radical expressions. First off, let's talk a little bit about simplifying. If I got this symbol right here, this is a square root. And if I look at the prime factorization, remember your primes are 2, 3, 5, 7, 11, sometimes 13. Those encompass 95% of your problems in algebra. I start my first prime, which is 2, and ask myself if 12 is divisible by 2, and it is. 2 times 6. 2's prime, so I circle it. I'm still on my first prime, which is 2, and it's divisible by 2. 2 times 3. 2's prime, so I circle it, and 3's prime, so I circle it. So prime factorization of this will be 2 times 2 times 3. Now, with a square root, we're looking for a pair of somethings. Here's a pair of 2's, so a pair of 2's is going to come out in front as a single 2. And we get 2 square root of 3. That would be our answer. Now you're not limited to just numbers. You can have x's. Now this is a cube root. By the way, a square root, the index, the number in the slot right here is 2. So the number in the slot here is a 3. Well, if I look at 16, that's 4 2's. If I look at x to the 5th, that's 5 x's. Now our index is 3, which means looking for a set of 3 of something. So I got 3 2's. They're going to come out in front as a single 2. And I got 3 x's. They're going to come out in front as a single x. So 2 came out as a single 2, 3 x's came out as a single x. Now we're left with a 2 inside, and we're left with x and x, which is x squared. And that would be our answer. So again, this index here tells you how many sets of what you're looking for. So looking for a set of 3 of something. If this was a 5 for the index, we'd be looking for 5 of something. And we had 5 x's, we could pull out 5 x's as a single x. Now that's our simplifying. Now for our addition. Say we've got square root of 5 plus 3 square root of 5. In order to add or subtract, your radicals have to be the same. Well, these are the same. Now the numbers that are in front, the coefficient can be different. In this case, there's an invisible 1 here, and there's a 3 here. When you're adding or subtracting, assuming your radicals are the same, you add or subtract the numbers in front. So we got 1 plus 3 gives us 4 square root of 5. Of course, the challenge becomes, how do you handle it when the radicals aren't the same? For example, let's say I had square root of 50 plus square root of 18. Well, if I do the prime factorization of 50, I got 2 times 5 times 5. If I do the prime factorization 18, I got 2 times 3 times 3. Now these are square roots, which means we're looking for a pair of somethings. Here's a pair of 5s, so they're going to come out in front. Here's a pair of 3s, so they're going to come out in front. So that's going to give us 5 square root of 2 plus 3 square root of 2. Now, when they were in this form, we couldn't do anything with them because the radicals aren't the same. But now, the radicals are the same, which means we'll add or subtract the numbers in front of them. 5 plus 3 gives us 8 square root of 2. And that'd be our answer. Let's look at a subtraction one. There we go. I think that'll work. Well, this is a square root. 3 I can't do anything with. But x to the third, that's 3 x's. 27 is 3 3's. I'm going to do the prime factorization. Now we're looking for a pair of somethings. Here's a pair of x's, so a pair of x's is going to come out in front. And here's a pair of 3's. So a pair of 3's is going to come out in front. If you already have something out in front, you multiply by what's already there. So this x comes out, and I'm left with a 3 and an x inside. And this pair of 3's comes out, so I have 3x square root of, and I'm left with a 3 and an x inside. Now notice that the radicals are the same. They're both square root of 3x. So I'll add or subtract what's in front. X plus 3x is 4x square root of 3x. Now this is assuming that x represents a positive number. If it represents a negative number and you're bringing out a variable, when you got an even index, you have to worry about putting absolute value bars around them. And the videos I got out there kind of go into more detail on that. It's kind of a fine point you don't see a whole lot in math. Now I've done three addition, but subtraction is just exactly the same way. If that was x minus 3x, we'd have a negative 2x out in front. Now for multiplication, if I got square root of 8, let's try it again. Square root of 6 times the square root of 15. First off, I would try to simplify the radicals. 6 is 2 times 3. 15 is 3 times 5. Not anything I can do simplification-wise. Now for multiplication, assuming your indexes are the same, what you do is you multiply what's underneath the radicals and put them underneath a single radical. So we're going to have 2 times 3, and that came from this first radical, times 3 times 5, and that came from the second radical. Now you don't want to multiply them together immediately because you're trying to see if you can simplify, if you can bring anything out. This is a square root for looking for a pair of somethings. Here's a pair of 3's, so a pair of 3's is going to come out in front. And we're left with a 2 times 5 inside, which is 10. So our answer is 3 square root of 10. Let's grab a drink here. Then we'll look at division. Now they call it division over here. It says divide radical expressions. It's actually called rationalizing. Kind of a weird term. But you don't actually divide. Just our simplification rule says you cannot have a radical in the denominator. You can also not have a fraction in a radical. Let me write those down. So fractions and radicals. No radicals in denominator. And no fractions inside of a radical. Those are our two main rules when we're talking about fractions and radicals. Right away, this one violates that. Because we have a radical, a square root, in the denominator. When you got a square root down here, like square root of 2, you multiply top and bottom by the square root of 2. We'll talk about y here in a minute. Up on top, that gives us 5 square root of 2. And on the bottom, since the indexes are the same, we multiply what's underneath the radicals and put them underneath a single radical. Now this is a square root, which means we're looking for a pair of somethings. Notice we have two 2's, so those two 2's are going to come out in front. So we get 5 square root of 2 over 2. This is why we multiply by the, if we got a square root, we multiply by that same square root. Because they'll basically cancel each other out and just give us the number underneath, or the variable. Now here, there's no radical in the denominator, and there's no fraction inside of a radical. So that's our answer. Let me give you a different one. 1 over the cube root of 2. Now you might think, well, you're going to just multiply by the cube root of 2, like the previous problem. No, your index is 3. That means we're looking for a set of 3 of something. I have 1, 2, so how many more 2's do I need? Well, I need 2 of them, because I need 3 of them total. And again, what you multiply by the bottom, you have to multiply by the top. And up on top, 2 times 2 is 4. And on the bottom, my index is 3, and so I needed 3 of something, and I have 3 2's. So 3 2's are going to come out in front as a single 2. And that's our answer. No matter what the problem is looking for, you have to look at the index. The index here is 7. Means we need 7 of something. Well, first off, 4. If I did prime factorization of that, that'd be 2 times 2. So it looks like we got 2 2's. But our index is 7, which means we need 7 2's. So if I got 2 here, I need 5 more 2's. And again, what you multiply by the bottom, you have to multiply by the top. Up on top, we got 5 2's, which is 32. And on the bottom, our index is 7. We have 7 2's, so that comes out as a single 2. And that's our answer. Now, one more type to look at for division. That technique works if you got a single radical down below. You can have a number in front of it, but the important part is a single radical. If, on the other hand you have a radical and maybe a number, or you can have 2 radicals. You can't just multiply the top and bottom by square root of 2. It doesn't go anywhere. What you have to do is you have to multiply top and bottom by the conjugate of the bottom. Now, what's a conjugate? Well, that means when the first part's the same, square root of 2, last part's the same, the 3. But the sign in the middle is different. This is a plus, so this will be a minus. And again, whatever we multiply by the bottom, we have to multiply by the top. 2 times square root of 2 is 2 square root of 2. 2 times negative 3 is negative 6. Nice part about conjugates is, all you have to do is multiply your first parts together and your last parts. Square root of 2 times square root of 2 is 2. 3 times negative 3 is negative 9. So this will give us 2 square root of 2 minus 6 over negative 7. Now, I might look at that and say, well, that's not simpler. That looks more complex. Yeah, but it doesn't violate any of the rules I gave you. There's no radicals in the denominator, and there's no fractions inside of a radical. So it actually works out. And that's the last topic there, I believe. Yeah. So let me go ahead and stop recording, and I'll answer whatever questions you have.